So what is a line of symmetry? In this case, you want to think about a face. So if you have a face, a line of symmetry divides it so that there's the same thing on both sides. Okay, so more or less, same thing on both sides, an eye on both sides of the line. So we look at this rhombus here, and we can definitely divide it that way and that way. Seems to be about it. Now this parallelogram, it's hard to see a line of symmetry. We can cut it in half, of course. Okay, so you'd say, well, this is a cut in half, but it's not exactly symmetry, right? So the symmetry would be more if it looked like this. So it doesn't seem like the parallelogram has any lines of symmetry. This guy, triangle's a little tricky, so you can, that looks good, and from the other angles it doesn't seem like it would work. So if you go from there, it doesn't seem like that one would work. How about for the star? That seems to be a line of symmetry that you can cut it down, but this one has more lines of symmetry. It seems from each of the points you could go. The octagon, I think you can divide it that way or that way. It's a regular octagon, so you can divide it. That's the pentagon. I think you can divide in this way, right? From that star, so perhaps from each star as well. Hexagon, definitely go that way. Seems like you can go that way. Can you go from each of these as well? Each time you can cut it into the two trapezoids, or you can cut it in half that way. Probably missing some on that. This one looks like you could do that. So you want to remember that triangle has two names. Okay, the first one tells about the angle, the biggest angle. The second one tells how many sides are equal. So we look at this one, and the biggest angle is a right, and the sides are all different lengths. Okay, so we have the short side, a longer side, the longest side. So this is a right scalene triangle. This one is also a right. So we have a right. But what does it have? It has two angles that are equal. So if the angles are equal, you might not have thought about this, but the sides will be equal. So there's two sides equal. So this is in right isosceles. So we want to draw a family tree. So let's start off with just a plain old quadrilateral. That's not a very good line. So there's a weird quadrilateral. Okay, it's not a trapezoid. There's no parallel sides. Well, there kind of are parallel sides. So let's say that even that one might have some parallel sides. So we want to draw one that has no parallel sides. So it goes, we'll start with a base. We'll go at an angle from the base, and then we won't go parallel to it, and then we'll come back. There we go. That is quadrilateral with no special characteristics. Now, you can have off to the side, you can have one parallel sides. So this is one pair, and there's a regular trapezoid, more or less. But you can also start having two pair of parallel sides. So you can have your parallelogram. Parallelogram. And then from the parallelogram, you can either go in the direction of having two sets of parallel sides with right angles, a rectangle, or you can say we have parallel sides and the sides are equal length, so the rhombus. Rhombus or a rectangle. And then you can say, okay, I got the rhombus and the rectangle. What if I put together those attributes and I say we're going to have equal length sides like here, and we're going to have right angles like here, so then we get the square. So the square is a rhombus. It's a rhombus, but it's a rhombus that has right angles, so it's also a rectangle. So it's hard to draw a regular pentagon, and so a lot of times I'll just try and draw close to a house. So think about a house when you draw it. Okay, so there's a house with bulging sides. Now what are the diagonals? Well, if you think about it, here's a point and it's connected to these 2 points. So how many points is this guy not connected to? Well, he's not connected to this one or to this one. So each one needs to go to 2 other places. So this one goes to 2 other places. Now this one needs to go to 2 other places, but one's already drawn, but one isn't drawn. There you go. You get this nice star from the diagonals. So practice making your diagonals. Okay, so when we look at the angle here, we can see it's more than a right angle. You can even take the corner of your paper and try and measure, and you'll see that it's greater. Well, how much greater? Oh, not quite 130, so not half again is great. Okay, so if you think about this being 180, then this, if you cut that angle in half, that would be about 135 degrees. You can see it's less than that, so let's say that that one is 120 degrees. Now here's a very acute angle, so let's say that that is perhaps 15 degrees, or 20 degrees. Well, how much is left? Well, 20 and 120 is 140. Altogether, they have to add up to 180. So you say, well, then this one would be 40. So now let's look again at this angle, and we see that, always go back to 90, and you think of half of that would be 135. So that's very close to 135. So we'll say, okay, this one seems to be 135. Now these 2 angles look pretty close to equal. So how much is left? 180 minus 135. There's 45 degrees left. So we'll call each of these 22.5 degrees. 22.5 degrees.